Welcome to the deep dive. Okay, let me paint a picture for you. You've just got this brand new state-of-the-art profile machining center. Supposed to be amazing, right? Runs lights out, super accurate. But then maybe 8 months down the line, bang. It grinds to a halt, mysterious alarm, maybe a horrible grinding sound. So you call the service tech. And after days of lost production, plus a repair bill that really stings, you find out the cause. It was something tiny, something that would have cost almost nothing to prevent. So today's deep dive, it's all about the single most important routine. Might seem boring, might get overlooked, but it's crucial. We're talking about that simple, maybe 15-minute daily maintenance check. This is what separates the shops that run smoothly from the ones always putting out fires. Honestly, it's the best way to keep that machine accurate and running reliably for years.
Exactly. And we're not talking about some complicated annual teardown here. The source material really hammers this home. Longevity. It's built on that daily foundation, that basic care. So we've boiled it down to 5 critical areas from the sources, things every operator needs to have down pat. Checking fluid levels, doing a really thorough cleaning, making sure lubrication actually gets where it needs to go, a quick electrical check, and finally, smart tool management. These little steps, they're what really protect that huge investment.
Yeah, the difference between like complexity and just consistency.
Yeah.
That's key. I remember that client story you mentioned from the sources. Just shocking. This company basically paralyzed by breakdowns.
Yeah.
Again and again, expensive ones.
And the cause wasn't some deep electronic failure, was it?
No, it was just neglect, simple neglect. Years of aluminum chips, oily grime just building up.
Right. It clogged up the drainage, the oil delivery lines.
Starving critical parts of lubrication.
Mm-hmm. And a basic daily cleanup. Just getting rid of the chips could have saved them, tens of thousands, plus weeks of downtime. It's incredible. So let's start there. Cleaning. Pillar number 1. Sounds basic, I know. Maybe too basic. But the stats in the source docs, they don't lie. Almost half of all unexpected equipment failures, they trace back to the environment. Dirt, dust, chips. Dirt is, seriously, the #1 enemy of a precision machine tool. Cleaning is, well, it's the cheapest insurance policy you can get against downtime.
Okay, but let's dig into the why. It's not just about making the machine look nice for visitors. What actual damage happens when you leave chips lying around, mechanically speaking?
Oh, it's definitely not just cosmetic. It's structural damage waiting to happen. Think about the chips that pile up on the linear guide rails. These things are built to incredibly tight tolerances. We're talking microns. So when tiny metal chips just sit there, the machine moves, eventually forces them right into the wipers. Those little rubber or plastic seals meant to protect the rail.
Okay. So the hard chip gets embedded in the soft wiper material.
Exactly. And suddenly that wiper isn't protecting anymore. It's turned into basically sandpaper. It crushes that chip against the super smooth, precision ground surface of the guide rail, and that causes tiny scratches, grooves. It's called scoring. And over time, that scoring just chews up the load-bearing surface. It destroys the machine's rigidity, its accuracy. Once that's gone, the machine can't hold tolerance anymore. And you're looking at a massive, very expensive job replacing the whole linear motion system. It's a slow death and totally avoidable.
Wow. Okay. So that 15-minute daily routine, what does the cleaning checklist actually involve? What needs hitting every day?
It's got to be a few things. First, the outside stuff. Wipe down the control panel, the windows, the painted metal surfaces. You have to get that oily grime off because it acts like an insulator, trapping heat. And trapped heat, that's terrible for electronics.
Yep.
Drives, relays, they overheat, fail way sooner than they should.
External surfaces. Got it.
Second, chip removal. This is huge. Brush, air hose, whatever it takes. Get chips out of the work area, off the fixtures, and definitely off those metal covers that protect the guideways. And empty the chip hopper. Every day. Don't let it pile up.
The sources also mentioned coolant. That seems like another area people might skip over. What's the common mistake there?
Yeah, the coolant tank often gets ignored. You absolutely have to skim off the tramp oil daily. That's the hydraulic oil or whey lube that leaks in and floats on top. If you leave it, bacteria grows in there, anaerobic bacteria. Makes the coolant stink, ruins your surface finish, cuts down tool life. It can even damage the coolant pump seals.
Okay.
And also clear out big piles of chips that settle in the tank or on the conveyor. Check the filters too. Are they clogged? Because dirty coolant, contaminated coolant, that just leads to poor results and wears out your tools faster.
Right. So chips are the enemy on the outside. What about the inside? That brings us to lubrication. You mentioned grinding noises, rough movements. If you hear that stuff, it means parts are already tearing themselves apart, right?
Pretty much instantaneously. Lubrication truly is the lifeblood. But, the biggest danger here, it's actually false confidence. Operators see the main lube tank is full, maybe they top it off, and they think, job done.
Yeah, seems reasonable.
But it's a dangerous assumption. The tank being full just means you have oil. It doesn't mean the oil is actually getting delivered to where it's needed.
Okay, so how does it fail then? If the tank's full, what stops the delivery?
Well, these central loop systems are complex. They have tiny little metering valves, small lines, often copper or plastic. If there's a blockage inside somewhere, maybe the pump itself fails, or maybe just one of those little lines gets pinched or damaged. Then oil isn't reaching the friction point. And without actually looking to verify, you could be running a multi-million rand machine dry for days, even weeks, before the big catastrophic failure finally hits.
Okay, that's scary. So let's unpack that verification. How do you avoid that false confidence? What are the steps?
All right, start with the simple stuff. Check the fluid levels daily. Central lube, hydraulics, coolant. Easy. But here's a critical point the sources really stress. Use only the lubricant the manufacturer recommends. A lot of modern machines have advanced components like linear guides that need very specific oil types, specific additives.
Right.
Using the wrong stuff, say oil that's too thick or has the wrong chemical makeup, can be almost as bad as using nothing. It might not flow into the tight spots, or it could even damage the seals.
And this is where that idea of trace the lines comes into play, isn't it?
Exactly. You physically have to look. Follow those small delivery lines that run out to the critical moving parts. Look for kinks, leaks, any signs of damage. Maybe a stray chip hit one or someone dropped a tool on it. Think about that little plastic line feeding the ball screw nut. That's what drives the axis movement. It's incredibly vulnerable. If that gets pinched, that ball screw is starved of oil.
And a dry guide block or ball screw nut. What happens then, failure-wise?
It's called galling, basically instant rapid wear. The smooth rolling action of the little ball bearings, gone. They start grinding, digging into the surfaces of the screw or the guide block rails. This creates backlash, friction, kills your accuracy, and forces a huge repair bill. Replacing those components costs thousands. So the absolute must-do step, confirm delivery. When that lube pump cycles, maybe it's on a timer, maybe you trigger it manually, the operator must see a little bead of fresh oil actually appearing at those critical spots. Bearings, ball nuts. If you don't see it, stop the machine, find the blockage, fix it, don't just hope for the best.
Okay, we've covered mechanical wear, friction, lubrication. Let's switch gears to the electrical side. Those really frustrating issues, the random alarms, the machine just stopping for no obvious reason. People often jump to thinking it's a complex software glitch or a board failure.
Right.
But the sources seem to suggest the real cause is often much, much simpler.
Yeah, that was one of the big surprises for me in the documentation. It really emphasizes looking at external factors first. The vast majority of electrical gremlins, they actually start as simple physical problems on the outside. Things like heat, vibration causing connections to loosen, or cables getting damaged. It's usually not some mysterious internal component failure.
That takes us right back to that story about the clogged fan, doesn't it? 2 days of lost production, big service bill, all because of, what, basically dust buildup. Seems almost embarrassing.
It really highlights the value of that quick 15-minute visual check, though. That system was overheating and the safety shutdown kicked in, which is good, it did its job. But the whole thing was preventable. The industry calls them penny failures, right? Tiny little oversight leads to massive downtime and cost.
So how do we build this electrical check into the daily routine? What are we looking for?
2 main things to check daily. First, cables and connectors on the outside. Look for any cuts, scrapes, or cracks on cables, especially ones that move or flex when the machine runs. And also, gently wiggle the plugs. Make sure all the electrical connectors are seated firmly. Vibration on these machines is serious. It's constant. And a slightly loose connector. That's probably the #1 cause of those intermittent faults that just drive maintenance teams absolutely nuts.
Okay, cables and plugs. And the second area is heat again.
Back to heat, yes.
Yeah.
Check the cooling system for the main electrical cabinet. Are the fans actually spinning? Are they spinning freely? If there are filters on the air intakes, are they clean? A clogged filter basically smothers the cabinet in a heat blanket. When drives and control boards overheat, their lifespan just plummets, or they just shut the whole machine down to protect themselves. And finally, use your ears. Just listen. Any weird buzzing noises, chattering from relays, a new humming sound from a motor or a pump. Often, a change in sound is the very first warning sign that, say, a motor bearing is starting to go, or maybe there's an electrical phase issue developing.
All right, our final pillar. This one ties part quality directly to the machine's health. Gutting tool management. If you start seeing parts coming off with bad finishes, maybe burrs, dimensions all over the place, the first instinct might be to tweak the feeds and speeds. But often the real problem starts with the tool itself being dull or damaged.
Exactly. And this is where we protect arguably the most expensive single component that rotates the spindle. A worn-out tool needs way more force, way more torque to cut the material compared to a sharp one. And that constant excessive load, it puts a huge strain directly on the spindle bearings and the whole spindle assembly.
And what does that extra force actually do to the spindle itself physically?
Well, it causes tiny deflections, like bending inside the spindle bearings and even the housing. Over time, this just hammers the bearings, wears them out faster. They lose their preload, their stiffness, and stiffness is absolutely critical for precision machining. Once that stiffness degrades, the spindle starts to vibrate more during the cut.
Ah, okay.
That vibration leads to worse accuracy. You get chatter marks on the part, which ironically damages the cutting tool even faster and puts even more stress back on the weakening spindle. You could literally cut the life of a, multi-thousand-dollar spindle in half just because you didn't change out a dull $50 end mill when you should have.
That definitely puts the cost of a new tool into perspective. So what are the essential daily checks for tool management?
The routine really starts before you even make a cut. Visual inspection every day is non-negotiable. Look closely at the cutting edges. Are they chipped? Are the corners rounded over? Is there obvious damage? If it looks worn, pull it. Replace it. Don't push it. Then, after use, clean the tools and the tool holders properly. Wipe them down. Maybe apply a very light coat of oil to prevent rust. Because rust, even a tiny bit, on that precision taper can cause problems when you load it back into the spindle. It can actually pit the mating surfaces.
And speaking of that taper, that connection between the holder and the spindle, that's the absolute critical point, isn't it?
It is the most critical point for accuracy in the whole toolpath, yes. The biggest operational mistake operators make is neglecting that interface. You have to train them every single time. Before loading a tool, wipe the taper on the tool holder clean with a fresh, lint-free cloth, and wipe the inside taper of the spindle itself clean, too. Any little bit of debris left in there, a tiny metal shaving, a speck of dust, even just a smear of old oil, it prevents that holder from seating perfectly concentric, perfectly true in the spindle.
And that immediately creates runout, right? The tool wobbles as it spins.
Exactly. Even a tiny amount of runout causes huge problems. Vibration, terrible surface finish, poor dimensional accuracy. Plus, it puts uneven stress back onto the spindle bearings and, ironically, can even damage the spindle taper itself over time. So that tiny chip you didn't wipe away, it ends up costing you precision, time, and eventually a lot of money. #tag outro.
So just to wrap up this deep dive, the main message from all the source material is crystal clear. The real difference between a profile machining center that runs reliably for years and one that's just a constant headache, a money pit. It boils down to consistency. Consistency in that simple, maybe 15-minute daily check. Those 5 pillars we talked about: cleaning, making sure lubrication is verified, the electrical check, managing your tools properly. They're not optional. They're absolutely essential. Think of them as the protective shield for that massive, complex piece of technology you've invested in. So what's the takeaway for you listening to this? If spending just 15 minutes doing a visual check, basically tracing the lines like we discussed, can stop a catastrophic multi-thousand-dollar failure in a really complex machine, it makes you wonder, doesn't it? Where else in your own life, maybe your professional routine, maybe even personal stuff, are you skipping that simple daily check, that little verification that could prevent a much bigger disaster down the road? What small connection point, maybe, are you just assuming is okay when it might actually be starving a whole system of something vital? That's maybe something to think about until our next deep dive.